Ethics. As the number of diabetic patients increases, the private health sector will find new and lucrative market opportunities. Market-driven research can deprive patients of cost-effective treatment modalities. There is ample evidence that health-related strategies, including those in the development of newer drugs, tend to be driven by the market rather than by people's needs. For example, companies have stopped production of cheaper forms of insulin, arguing that human insulin is more physiological. However, the cost difference is phenomenal. The word ethics comes from a Greek term meaning duty. Code of ethics consists of all the obligations that professionals must respect when carrying out their duties. It's a code of professional conduct. Code of ethics is usually established by a professional order as a way to protect the public and reputation of the professionals. There are a few published code of ethics for biotechnology. For example, Australia's Biotechnology Organisation Code of Conduct, and Queensland Biotechnology Code of Ethics for Bioremediation and Bioprocessing. Sustainability. Sustainability is the ability to continue a defined behavior indefinitely and can be further grouped into three categories: environmental sustainability, social sustainability, and economic sustainability. Useful environmental indices for biologics manufacture should also include energy consumptions and waste generation, and waste generation would include aqueous wastes and solid wastes. Aqueous wastes generated from cleaning and sterilization operations are considered innocuous and discharged as municipal wastes. Solid wastes, which include filters, membranes, resins, tubing, and disposable equipment, are treated as a biohazard and are typically autoclaved and then landfilled or incinerated. The table shows that for each kg of insulin produced, more than 30,000 kilograms of processed water is consumed along with over 4,000 kilograms of organic solvents, some of which are hazardous. Also, about 15 kilograms of consumables like solid processing aids are used per kilogram of insulin produces. These values, especially for water and solvents usage, are very high and represent a unique, extreme case for biologics manufacture due to the length of the purification process and the complex reaction steps. ISO 14001 is a voluntary international standard that specifies requirements for an effective environmental management system with benefits like reducing waste, drive down cost, improve resource efficiency, improve overall environmental impact, manage environmental obligations with consistency, and provide assurance that environmental impact is being measured, appraised. Type 1. Human insulin. Human insulin is extracted from pancreas cells and an insulin-producing gene is isolated. A plasmid DNA is extracted from a bacterium and cut with a restriction enzyme, forming plasmid vector. Insert human insulin-producing gene into the bacterial plasmid vector to form the recombinant DNA of human insulin-producing gene. Introduce this recombinant DNA into a bacterial cell to form the recombinant bacterium. The recombinant bacteria multiply in the fermentation tank and produce human insulin. Insulin is extracted, purified and bottled. It is then ready to be injected into diabetic patients. Type 2, proinsulin method. The sequence that codes for proinsulin is inserted into the non-pathogenic E. coli bacteria. The bacteria go through the fermentation process where it reproduces and produces proinsulin. Then the connecting sequence between the A and B chains is spliced away with an enzyme and the resulting insulin is purified. Type 3, analog insulin. Similar to human insulin, analog insulin is laboratory created by growing insulin proteins within E. coli bacteria. The order of amino acids is then changed to allow the insulin to be used by the body either more rapidly or more uniformly by the body than with regular human insulin. This process is known as recombinant DNA technology. Advantages of E. coli include simple, well-understood genetics, ease of genetic manipulation, minimal culturing cost, fast expression where doubling time is only 20 to 30 minutes, ease of scaling up in fermentations, ease of inclusion bodies purification, well-established labeling protocols for stability studies and established regulatory track record. On the other hand, disadvantages of E. coli includes loss of plasmid and antibiotic property, unsolicited inducers for gene expression, lack of post-translational modification, endotoxin contamination, poor secretion, improper protein refolding and protein-mediated metabolic burden and stress. Thank you for your attention.